Okay, Wildcats. Today we're looking at 3. Samesies comparing multiple representational functions. Okay, the warm-up. Rewrite each expression as a different equivalent expression. So let's take a look at questions 1, 2, and 3. Okay, question 1. Here we just distribute 7n times 3n is 21n squared. 7n times 1 is plus 7n, and you're done. All right, let's take a look at 2. Here we have to work backwards. So we know first term, last term, and we have to figure out, well, what multiplies to give you x squared? The answer to that is x and x. Now, the next thing we need to do is figure out the middle term. Well, the middle term is technically x squared plus 0x. The middle term is technically 0x. Okay? So we need to figure out what numbers multiplied to give you negative 25 combined to be 0x. Well, the only logical number that makes sense is 5 and 5. So plus 5 and negative 5. So x times 5 is 5x. Negative 5 times x is negative 5x. 5x minus 5x is 0x. Negative 5 times 5 is negative 25. So this factors to be x plus 5 times x minus 5. Let's take a look at number 3. All right, so here squared means that's 4w plus 2 times 4w plus 2. So now we FOIL 4w times 4w is 16w squared. 4w times 2 is 8w. 2 times 4w is plus 8w. 2 times 2 is plus 4. Now we combine terms. 8w and 8w is 16w, so that's 16w squared plus 16w plus 4. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. All right, getting started. Odd one out. Consider the relationship shown by each of the given representations. Tell if the relationship is a function or not a function. All right, so to do that, let's take a look at relationship A. If I draw a vertical line through the graph, it crosses twice or more than once, not a function. So relationship A is not a function. Okay, so now let's look at relationship B. If x does not repeat, it is a function. If x does repeat, it is not a function. So here, let's take a look. X does not repeat, it's a function. Okay. All right, so let's go look at relationship C. So to graph this, graph 1, 2, 3, 4, 5, 6, 7, 8. So we start at 8, and we go down 3 to the right 4. So down 1, 2, 3 to the right 1, 2, 3, 4. 1, 2, 3, 4. Down 1, 2, 3 to the right 1, 2, 3, 4. So there's our line. We draw a vertical line through it. It only crosses once, so it's a function. So not a function, function. Okay, now to look at D, if x does not repeat, it's a function. If x does repeat, it's not a function. So here, Zeke has one app on his phone. When he buys it, he downloads a different number of apps each week. Total number of apps on his phone doubles each week. So he starts with one app, then he has two, then he has four, then he has 8, then he has 16. The x's do not repeat, so this is a function. So relationship A is not a function, and A is a function. I'm sorry, B is a function, C is a function, and D is a function. All right, so go ahead and finish up that page. All right, let's take a look at the next page. Activity 3.1, Equivalent Representations. Understanding patterns not only gives insight into the world around you, but also provides you with a powerful tool for predicting the future. Pictures, words, graphs, tables, and equations can describe the exact same pattern, but in different ways. In the previous lesson, you used a visual model, graph, table, and context to describe the relationship between the number of days that have passed and the total number of seniors that learned the results of the homecoming king election. In relations such as this one, there is only one output for each input. This type of relation is called a function. Functions can be represented algebraically using function notation. All right, step 1. Cut out the relations provided at the end of the lesson. Analyze each relation and then create a group of equivalent relations. All relations have at least one match. And I believe you're cutting out pages 139 to 144. So cut out pages 139 to 144. Okay, then you're going to glue this here and this here. So you're going to glue B and V, and you're going to make a chart for equation, table, graph, and words. Now in this case, B and V have no words that glue down. Okay? All right, let's take a look at the next page. All right. Then again, you're going to make a table, graph, and words, and you're going to glue down this. You're going to glue down I, and know that I and F are the same, so you can just add that there. You're going to glue down N, and then look for the pieces. And then D, you just need to know that this D, P, and H are the same, and then find the table graph, and then the words is none. All right, so go ahead and cut those out, finish it up, and let's take a look at the next page. All right, activity 3.2, equivalent functions. A ceramic tile company creates a new line of decorative kitchen and bathroom tiles. The company sells designs that are created from a combination of small gray, white, square tiles. The designs follow the pattern shown. Okay. Analyze this design, describe all the various patterns that you notice. The center gray square has dimensions that are an odd number. So now we need to, the teacher is going to work the white tiles, the students will work the gray and the total. Okay, so let's take a look. So the white tiles are 3, 3, 3, and 3. So 3, 6, 9, 12. And then here, this is 2, 4, 6, 8, 10. So this is 10, 10, 10, 10. So 10, 20, 30, 40. And then 3, 6, 9, 12, 15, 18, 21. So this is 21, 21, 21, 21. So then that's a total of 84. Now, to find 4, 7, 10, we need to find the equation. Okay, to do that, let's use regression. Okay, so I'm going to go to Desmos, graphing calculator. Statistics, linear regression. We're going to try linear first. So let's change the table. So then we have 1, 2, 3, 12, 40, 84. Now, you can see the r squared is not 1, so this is not an exact match. Okay, so let's try now quadratic. So, Desmos again, graphing calculator. Statistics, we always have to pick linear, and then we have to go, now here we're going to change this to quadratic. Oh, x1 squared plus bx1 plus c. Okay, now we just need to change the table. We have the quadratic regression. So now let's complete the table. So 1, 2, 3. So then 12, 40, 84. Now you can see the r squared is 1, so this is a perfect match. So this is a quadratic regression. So our equation is 8n squared plus 4n plus 0. Okay, now we're going to use that to find 4, 7, and 10. Okay, so here our regression is good, but now let's go to Desmos scientific calculator, and we're going to do 8 parentheses 4 squared plus 4 times 4 plus 0. Okay, and so we have 144. Now let's do 7. So 8 times 7 squared plus 4 times 7 plus 0 is 420. And then now we're going to do 8 times 10 squared plus 4 times 10 plus 0 is 840. Okay. So there we go. Now the student's going to work the gray and the total. And then once you've done that, you can answer number 3. All right, let's take a look at the next page. All right, the student works 4, 5, and 6. So the student works 4 and 5 and 6. And then you can omit or skip 7. All right. You may have noticed that several patterns in sequence. An obvious pattern is that the sum of the white tiles and gray tiles is equal to the total number of tiles. The pattern is clear when analyzing the values in the table. However, adding Wn and G of n creates a brand new function that looks very different from the function T of n. So there you go. Analyze context table and express in this problem. Identify the function family that describes the pattern for the number of white tiles. The function that represents the white tiles is quadratic. The algebraic representation is in the form of ax squared plus bx plus c. The student works b. Or a to b, I should say. All right. Let's take a look at the next page. All right, we're going to scratch this page. All right, let's take a look. All right, student works 1A, 1B, and 1C. All right, let's take a look at the next page. All right, the student works 2A, 2B, and 2C. And then the student works 3A and 3B. All right, go ahead and finish your work in the book and your assignment, and have a wonderful Wildcat day.